Well, hello there. I'm Mr. Von Ah, and we are back for some more algebra. Hey, I'm here to help you in any way I can. So this is a very, very important video. We've learned how to write equations, and now we're going to learn the strategies or the tools that we need to solve linear equations. All right? In the description below on this video, you'll see my notes that I posted for this lesson. Go ahead and print those out as you feel led to do so. All right, so what's a linear equation? What do I mean by linear? Well, really a linear equation, we call it that, is because when you graph it, it forms a straight line, right? There's no curve. It's a straight line, so it's linear. Okay, how do we identify a linear equation? Well, a linear equation simply means it is an equation I wrote the definition much better in my notes. It's an equation whose variable has an exponent of 1. All right, so any linear equation, the exponent is going to be a 1. So for example, if I have 2x plus 3 equals 4, right? If you look at the variable, the exponent actually is a 1. You don't see it, but it's actually a 1. So whenever you don't see an exponent, it means it's a 1. All right, if that was a 2, for example, that would not be a linear equation. That's actually a quadratic equation, which we're not going to get into. That involves a different set of tools that we would need to solve that. Okay, so a linear equation, right, has the variable has an exponent of 1. All right, and its graph forms a straight line. All right, so a solution. What's the solution to a linear equation? Oftentimes you'll say, well, what's the answer? What's the answer? Well, in algebra, we don't say what's the answer. We say, what's the solution? All right, so the solution is the value of the variable that makes the equation true. That makes the equation true. So for example, I won't use this because it's going to give me a goofy number. If I had 2x plus 3 equals 5. What is the value of that variable that makes this equation true? Well, how about let's try 1. 2 times 1 is 2. 2 plus 3 is 5. So the solution would be x equals 1. That's the solution. Not the answer, the solution. Again, it's the value of the variable that makes the equation true. All right, that being said, let's get right into some of the nitty-gritty here. All right, so what I want to do is I want to equip you with some strategies or some tools that will help you solve any linear equation. All right, so I got a little toolbox here, right? You'll see that in the notes. So we're going to go ahead and fill in our toolbox. All right, so the first tool that you're going to need to know is the distributive property. Distributive property. And what the distributive property is basically is if I have some number multiplied, that number, that letter A, is being multiplied by the B and the C, right? The B and the C are in a grouping symbol which says, hey, you got to multiply both of us. A is being multiplied by both, not just to the B. Well, if that's the case, then you get A times B, which is AB, and you get A times C, which is AC. All right, so there's the distributive property right there. Yeah, not so bad. Okay, so if I wanted to put some numbers on that, if I said 2 times x plus 3, something like that, right, you just distribute the 2. So I get 2 times x and 2 times 3. Okay, so I would get 2 times x is 2x, and 2 times 3 is 6. All right? So very, very, very important tool for you to have in your toolbox, the distributive property. All right? And by the way, when you are solving linear equations, that's going to be typically the first thing you're going to do, if you can do it. All right? Secondly, combining like terms. Combining like terms. A like term is, well, they're just terms that are alike, right? So, for example, if I had, let's use brown here. If I had 2x plus 3y plus 2x, that's a y. Okay, do you see any like terms there? Well, these two are alike, right? Why? Well, because they both have an x in them, right? So this would be 2x plus 2x would be 4x. Now that y, that 3y, he doesn't have a like term. So we have to just leave him by himself. He doesn't have anybody to join with, right? So it's as simple as that. Combining like terms is just looking for those terms that are the same and either adding them or subtracting them together. All right? That's going to be the second thing you do typically when you're solving linear equations. Not always, but in the order, that's the priority it gets. All right? Toolbox number 3, or tool number 3 in our toolbox, is the addition principle. And the addition principle is, let's see, adding the opposite, I don't know if that's spelled correctly, adding the opposite to a number in order to get 0 as the result. In order to get a 0 as a result. So for example, if I had let's go x plus 2 equals 5. X plus 2 equals 5. That's an equation. That's a linear equation. Well, there's no distributing to do there, is there? And there's no like terms. These two are alike, right? But they're on opposite ends of the equal sign. They have to be on the same side of the equal sign to be like terms. So I use my addition principle. So I have this 2, right? I want to solve for the x. That means I want to get x equals. To get rid of that 2, what do? I just add its opposite. Well, what's the opposite of plus 2? You got it. It's minus 2. So I subtract 2 to both sides, and what do I get as a result? I get 0. I get 0. So my solution would be x equals 3. Now you might be thinking, well, I don't even really need to learn the addition principle because I could have just done that in my head. True, but trust me, there's going to be lots of problems. Most of the time you're not going to be able to do it in your head. You're going to need this tool. Trust me, it's kind of like a screwdriver. You know, sometimes you can just loosen something with your hands, right? But most of the time you need a screwdriver, you need a tool. All right? So the last tool that we need to talk about is the multiplication principle. The multiplication principle is just simply multiplying a number by its reciprocal. Oh boy, there's another word we haven't we talked about. Reciprocal. Reciprocal just simply means changing the numerator and the denominator around. So if you have 1/2, the reciprocal would be 2 over 1. Right? I'm just flipping the number. So by its reciprocal, to get a result of 1. It's probably not the most eloquent definition, but I think it works. Multiplication principle is simply just multiplying a number by its reciprocal in order to achieve a result of 1. Let me show you a couple of examples. I'm going to show it to you over here. Because in my toolbox, I've run out of room, but in your toolbox, you have room. So in your toolbox, just write it down here. Okay, so for example, let's say I have 1/2 x equals 6. 1/2 x equals 6. Okay, do I have distribution that I need to do here? No. Do I have any like terms that I need to combine? No. No like terms. Addition principle, am I adding or subtracting anything? No. So my last resort is multiplication principle. I am multiplying. I'm multiplying 1/2 times x. Okay, so what do? I just simply multiply by the reciprocal. Well, what's the reciprocal of 1 over 2? Reciprocal of 1 over 2 is 2 over 1. All right, I just take it and flip it around. Okay, but I got to do it to both sides. The golden rule of algebra is do unto one side as you do unto the other. Okay, so I multiply that. Now 2 over 1 is just the same as 2, right? So I'm just going to go ahead and multiply that by 2, if it's okay with you. All right, so what do I get here? What's my result? What's 2 over 1 times 1 over 2? Well, 2 times 1 is just 2, correct? So I get 2, and 1 times 2 is 2. And of course, 6 times 2 is 12. So what's 2 divided by 2? 1. So x equals 12. Right? So anytime you multiply a number by its reciprocal, the answer is 1. Always. Anytime you multiply a number by its reciprocal, you're always going to get a 1. All right? So that's the multiplication principle. Now, most of you probably have not learned it that way. Most of you have probably seen it this way. Let's make some more room here. So let's say I had 2x equals 8. All right? Now, this is multiplication. Okay, I could multiply this by the reciprocal. What's the reciprocal of 2? Well, the reciprocal of 2 is just, 2 is 2 over 1. The reciprocal would be 1 over 2. So if I multiply this by 1 over 2, I would get a 1 here, correct? But I want you to notice something. Notice that this 2 is in the denominator, right? And isn't 1 times 2 just 2? So if I just pull this 2 over into this denominator, essentially, what did I do? I simply just divided by 2. Check it out. Division is the same as multiplying by the reciprocal. All right? It's the same exact thing. Division is just multiplying by the reciprocal. So I can multiply by the reciprocal, or I could divide by the number. Either way, you get the same thing, right? Because when I divide both sides by 2, what do I get as a result here? 2 divided by 2 is 1. So I get 1x, or just x, equals 8 divided by 2 is 4. All right? So you can put these 2 examples down here in your little toolbox. All right? So these are going to be the strategies that we're going to use to solve equations, linear equations. All right? In our next video, we're going to actually tackle some some equations using these tools. So make sure you join me for that video. As always, make sure you subscribe to my channel. That way you get notified anytime I make new videos. And make sure you check out the description in the below. It's got a link to the notes to this lesson. All right? Well, God bless you, my friends. Take care of yourself.